Hey guys, so in this video we're going to have a little look at Pythagoras' theorem. And Pythagoras is a guy who discovered this thing about triangles, and this only applies for right-angled triangles. And I've written it in words here. This is what he discovered. In a right-angled triangle, the hypotenuse squared is equal to the sum of the squares of the two shorter sides. So if you haven't come across that word hypotenuse before, the hypotenuse is the longest side on a right-angled triangle. So you might describe this as the diagonal line in a triangle. It's the longest side in a right-angled triangle. And then that leaves the other two sides there must be the shorter sides. Okay, let's have a go at this in action. So what I want you to try is getting a piece of paper and cutting out 4 identical right-angled triangles. So maybe use the corners of your paper to help you get the right angles perfect, and make sure those triangles, those 4 triangles that you cut out, are all the same size and shape. Okay, and once you've done that, you can arrange them to look like this. So you're arranging them in a square, and you can see they're facing inside the square is my my longest side of the triangle there, the hypotenuse. Now once you've got it drawn like this, you might notice that this black square here will have an area equal to whatever this length is times whatever that length is. Okay, in fact these two lengths are the same, aren't they? These two lengths are both the hypotenuse. So if I've labelled the hypotenuse as c here, then this area is c squared. It's the hypotenuse squared. Now, what I want you to do next is take your triangles that you cut out, each one of them, and I want you to try and rearrange them in this same square, in the same big square here. Can you rearrange those triangles so they look like this? I'll let you have a little quick go at that. You can pause the video, or I'll show you next. So I've made a little animation here to show you how you can move these triangles into this new position, and there you have it. So you've got it moved into that position, and now you'll see hopefully that we've created 2 smaller squares. So I've got this small square here, and I've got this also smaller than this one square here. Now if this length was, we labelled it here as A, that length there is also the same as this length here. They're both A, so this leaves us with A squared as that area. And for the other square, this length here, or this length here, okay, they're both the same as this one. So this would be B times B, so that makes B squared. And actually, inside this shape here, and inside this shape here, when we moved those triangles around, the amount of empty space should have stayed the same, shouldn't it? So we know that these two guys added together are equal to this one. So sometimes you'll see Pythagoras' theorem written as a squared plus b squared equals c squared. But what we're really saying is that the sum of the squares of the 2 shorter sides is equal to the square of the longer side. So let's have a look at a quick example, or a couple of quick examples. So here I've got a triangle, and I want to work out what this missing side is. So I'm going to write out Pythagoras' theorem. So it says here, in a right-angled triangle, the hypotenuse squared is equal to the sum of the squares of the 2 shorter sides. So this is my hypotenuse, so it's called x, so we can say x squared is equal to the sum of the squares of the 2 shorter sides. So that means 3 squared plus 4 squared. Now if this makes x squared, but I want to know what x is, what's the inverse operation? What's the opposite of squaring? It's a square root. So I'm going to square root 3 squared plus 4 squared, and that gives me x is equal to the square root of 9 plus 16, so that makes the square root of 25. What is the square root of 25? the square root of 25 is 5. So that'd be 5 centimeters. Okay, I could do the same for the next triangle down here. So remember, we're going to write out Pythagoras' theorem again. So the hypotenuse squared. So the hypotenuse now is this length here, so that's 13. So 13 squared is equal to the sum of the squares of the two shorter sides. So this side squared plus this side squared. So 12 squared plus y squared. And now you might have to do a little bit of rearranging. Think about your fact families. If these two add together to make this one, then that means that y squared is equal to 13 squared, take away the 12 squared. I'm running out of space here, aren't I? Let me move this over. So I could say that y is equal to the square root of 13 squared minus 12 squared. And this just so happens to make the square root of 25, which also equals 5. So we can say that y equals 5 centimeters. Let's put it here. There we go. And that is a quick look at Pythagoras.